Yes. So you are given a connected graph, then you can find out tree subgraph from that. That is another story. Tree subgraph may have any number of vertices from G, not necessarily all the vertices of G. But if you want to find out, or if you want to take all the vertices of G, then that is termed as spanning tree. Both are subgraphs, but spanning contains all vertices. Okay. Now, if the graph is weighted, then again you can find out many spanning trees, which will be again weighted. But our interest is to find out the shortest spanning tree. That means the spanning tree whose weight is minimum. Okay? So that we are going to do now. Right, shortest spanning tree or minimal spanning tree. Shortest spanning tree or minimal spanning tree. Let G be a connected weighted graph. Let G be a connected weighted graph. A spanning tree of G with minimum weight, a spanning tree of G with minimum weight is called the shortest spanning tree. A spanning tree of G with minimum weight is called the shortest spanning tree or minimal spanning tree of G. Shortest spanning tree or minimal spanning tree of G. Next, write a remark. Connected weighted graph G. A connected weighted graph G can have more than one can have more than one shortest spanning trees. Can have more than one shortest spanning trees. Okay? It is not necessary कि एक ही होगा. A connected weighted graph can have more than one shortest spanning trees. For example, no talking trees. Suppose I take graph. So this is a connected graph. B, right? Iftisam, don't discuss about eigenvalue. This is a connected graph with many circuits. I want to find out shortest spanning tree. Okay. Of course, we are going to study an algorithm. I am just taking this as an example. So, common sense क्या कहता है? I want shortest. That means I should choose only minimum weights, right? But at the same time, I have to take care that the edges which I am going to choose with the minimum weights should not create any circuit in the graph, as well as the graph should become a connected graph. ये दोनों चीजें सेटिस्फाई होनी चाहिए. A circuit free connected graph. I should get a tree. बोल. Tell me which edges I should select. I want to find the shortest spanning tree. I should start with the smallest value. CD 1, 1. Then now if I choose 2, 4 है ना? Has it become a tree now? Yes. So I should stop here. ये tree बन गया ना? 4 vertices, 3 edges. Okay? And it is not creating any circuit. It is connected. So this is one answer. Or I can have this 2, 1, 1. Answer कितना है? 4. Right? Or I can have so this is what we have written remark में a graph can have more than one shortest spanning trees मतलब weight same है 4 but the structures are different or the trees are not isomorphic. You understand it? But this is a small graph, so I can find out like this. I can find out the shortest spanning tree. But if the graph is big, then I should have a step-by-step procedure, which is called as algorithm, right? I should know how to make a spanning tree without any circuits, and the graph should be connected one. Okay, so that for that we are going to have Kruskal's algorithm, last topic of the day. Be quick. Kruskal's algorithm, Kruskal's apostrophe S, Kruskal, Kruskal's algorithm to find the shortest spanning tree. So what Kruskal says? Kruskal says that you list out all the edges first of all and their weights. Then you arrange them in the ascending order of the weights. You arrange the edges in the ascending order, then go on including the edges. The edge which you are including, strike out that from that sequence and include those edges which do not form any circuit. Okay? So let us have one example. It's very easy to understand. 5 marks question. So write the question. Find the shortest spanning tree of the following graph. Find the shortest spanning tree of the following graph using Kruskal's algorithm. Using Kruskal's algorithm. It's 7 and 10. Not able to see. So the names of the edges also I am writing, but it is not necessary कि आपको graph में edges के नाम भी आए. Okay? So you have to be careful there. 4 का weight है 7. Then E8 का weight है 8. ये है E8. This is E7. इसका weight है 4. E6 इसका weight है 9. This is E4 का weight है 4. E1 E2 this is E3. E5 का weight है 12. Then this is 12. E11 का weight है 5. E10 का weight है 7. E9 का weight is 7. Hope कुछ लिख भी गया है. Okay, so principle says that a spanning tree means I should have all the vertices, right? So I'm just putting all my vertices. Okay. So you have to write age, weight. 1, E2, E3, E4, E5, कितनी एजेस है? Okay, so E1 का weight है 4, E2 7, E3 8, E4 4, E5 12, E6 9, E7 4, E8 8, E9 7, E10 7, E11 5, and E12 10. This is how you have to write the weights. Okay. Now these weights are not arranged in any order, right? They are arranged in the order of the number of ages, right? One into ऐसे arrange किए. So right, इसके बाद arrange the ages. Arrange the ages. The order of the weights. Arrange the ages in the ascending order of the weights. Arrange the ages in the ascending order of the weights and include the age in the spanning tree and include the age in the spanning tree. Include the age in the spanning tree if it does not form any circuit. If it does not form any circuit. Okay, so we are rearranging this now. तो मैं यहीं पे rearrange कर लूँ. E1 4, मिनिमम वैल्यू क्या है? 4. उसके बाद कौन आ रहा है? इससे E4 4. E4 भी 4 है. फिर 4 चला गया. E7 is also 4. 4 के बाद क्या है? 5. 5 किसका है वेट? 11. There is only one 5. E7 चला गया. 5 के बाद क्या नंबर है? 7. 7 के 2 है मेरे पास. पहला कौन सा है? E2. E2 7, E9 7, E10 7. फिर E8 8 है ना? E3 भी है ना? E3 and E8 both are 8. So E3 8, E8 8, E6 9, then E12 10, and E5 12. 11 भी है ना रे? Okay, sorry ages. So we have rearranged them in the ascending order of their weights. Please don't discuss anything else. This is equally important. हाँ? हो गया ये? We will start including the ages as per their weights, starting from the least one, because we want shortest. So E1 कहाँ पे है? Yes, E1, right? तो ये यहाँ पे cancel हो गया. E1 ले लिया. Can I take E4? Every time you ask whether it is creating any circuit. E4, where is E4? V2 to V3. So it is not forming any circuit, right? So I can take that. Or you can please put a tick mark. Tick mark dalo. Okay. Then E7 is 4, that is V4 to V5. It is not creating any circuit. So I can include that also. Girls, are you getting it? यहाँ पे देखो आपके सीक्वेंस में देखो ये रीअरेंज सीक्वेंस लिखा क्या सबने? हाँ. Now next E11. Can I include E11? E11 with weight 5. It is not creating any circuit. Yes. Then E2. E2 weight is 7. So if I include that here, does it create any circuit? No. So far no circuit, right? Next. Now E2 हो गया. E9. E9 is 7. So I can include that. It is not creating any circuit. Then E10. E10, if I include this, then it is creating a circuit. So I am not including E10. Got it? ये मैं include नहीं कर रही हूँ. You can put a cross mark. Then E3A. E3A. 3A यहाँ पे मैंने किया तो no circuit, but ये कर सकती हूँ ना मैं. तो ये कनेक्ट कर रहा है ना. अभी देखो ये सारे वर्टाइसेस कनेक्ट हो है ना. ये कनेक्ट नहीं हो रहा था ना, ये कंपोनेंट हो रहा था ना. इस एज से क्या हो गया, ये सारा कनेक्टेड हो गया. सो हाउ मेनी वर्टाइसेस आर देयर? 8. हाउ मेनी एजेस आई शुड गेट? 7. A tree on n vertices has n minus 1 edges. So E3 मैंने ले लिया. So 1, 2, 3, 4, 5, 6, 7. The graph had 7 edges. I have got a circuit-free connected graph with possible minimum weights. हाँ? तो इसका आंसर कितना आया अभी? 4 plus 4, 8 plus 4, 12 plus 5, 17, 24, 31, 39. So you will get 2 marks for this diagram and this. अगर 3 marks का question है तो 2 marks for this arrangement diagram and 1 mark for this answer. Is that clear? Have you understood it? समझा नहीं है अगर तो पूछो. अलीन समझा है क्या? Every time whichever age you are including, that should not form any circuit. Okay? Siley, I am ending the meeting.
Yes, ma'am. Thank you.